I mean, like,
Most people will quote it, but then you get people that take it like overboard and pass it. So,
I mean,
A what one?
the yellow one, they're school calculators.
What do you mean school?
Okay, when they brought these out,
Uh-huh.
no, let me stop. When they brought these out, if you had the school bus yellow one, it was sold only to schools.
Really?
So my principal would go into pawn shops and find the yellow one.
Yeah, I don't know where I got this one,
Well,
but
you don't, actually, the calculator doesn't say it's just
yeah.
your yellow top, but yeah, they sold only the school bus yellow ones to the school. My friend won't be here today, she's got a sick kid,
Okay.
and I have to leave.
Okay. All right, so Monday, the 24th. Yeah. Okay, so our first exam is on Monday. All right, so next time we meet. So I did prepare a review for you. There it is. Okay. So I have a review that I will hand out when I finish covering what I need to cover today. Okay? And the way the review is going to work is you're not going to turn it in for a grade or anything like that. I'm going to post the solutions to the review, but I will just post the answers. I'm not going to post any of the work. So hopefully I'll get that posted within the next day or two. And that way you can go practice it, see if you're getting the answer. If you're not getting the answer, then that means you need to go get some help with the tutor, contact me, we can try and figure it out. But I don't want to just give you the full blown out, worked out problems, because that doesn't really help you prepare for the test. All right, so we will talk about that. So today what we need to do is finish up those basic formulas. Basic derivative formulas. And just to be clear, because I think there was some confusion with the homework, when it comes to finding the derivative of a function, at this point, there's two ways to do it. There's the way that we use the limit definition. Okay, so let me clarify this. If I ask for f prime of x, right, if I ask for the derivative of a function, we have one, use the limit, and that means you have to use this very nasty limit h goes to 0, f of x plus h minus f of x all over h. You actually have to grind this thing out, try and get things to clean up where your h's cancel, and then at the end take your limit as h goes to 0. That's what you were supposed to do on those homework problems. That's the first way. The second way is to use the formulas. So on the exam, just like on the review, I say here, find f prime of x using the limit definition. That means I'm telling you have to use that, okay? If I don't tell you to use the limit definition, then that means you can use the formulas, all right? And also remember that even if you have to use the limit definition, you can use the formulas to check your answer, to make sure you got to the same result. Because you should get to the same answer either way, okay? So what I'm going to do now is finish up what we were talking about last time, which was the derivative formulas. So let's list them out, the ones that we already talked about. The first one was Do you remember? We said if your function is just a constant, right? I use c, right? Then the derivative of any constant was what? 0. Okay. The second formula I gave you was that if f of x is just x, the derivative is 1. And I tried to convince you of those with a little bit of geometric proof. And then the third formula was that if f of x is any power of x, right, that the derivative is what? I forgot. What is it? It's the n times x raised to the n minus 1. That's what it is. And this we called the power rule. Very, very powerful rule. And I told you to just take it on faith, and I wasn't going to prove it to you, but if you wanted to see the proof, you could come to my office. I could show you. All right? Okay? So this rule, the way it works is if you have x to a power, all you do is you bring the power out front, and you subtract 1 from the power. That's it. And that's the answer. No more work needs to be done. All right, so let's continue. Those are the only ones we did, right? Yes? In your notes? That's it? Okay, the fourth one is kind of weird, but check this out. If you have a constant, c, times a function, all right? Then, watch the way I write this. If we take the derivative of this, so here's how I'm going to let you know I'm taking the derivative. I'm going to put it in parentheses, and I'm going to put that little prime mark that we've been using here. That prime means take the derivative, all right? So you have a constant times a function. Then if you take the derivative, this is equal to the constant times the derivative of the function. Okay, this can be confusing because it's all in letters and stuff. Let's do an example, and you'll see that this is no big deal, all right? Okay? So here's how this works, Formula 4. So let's say we have a function. Here it is. Actually, let me call it something other than f. Let's call it c for cost. Like, let's say we had a cost function, all right? And this was equal to 4x to the 7th power. And let's say we're asked to find c prime of x, which is its derivative, right? That's what that means? Then this rule right here says that if we see a constant in front of some function of x, that when we take the derivative of that, what happens to the constant? It just stays there, okay? It doesn't go away. And then all you have to do is take the derivative of that other part that was the function of x. So in this illustration here, this right here is our constant, and this right here is our function of x. Do y'all kind of see how that works into the formula here? So according to this, it should be 4, right? The 4 is just going to, I always tell my calculus students, the 4 is just going to come for the ride. Okay, it's just going to come along with us for the ride. 4 is going to just be there, okay? And then you have to take the derivative of this. And which rule will I use to take the derivative of x raised to the 7th power? The power rule, right? And we have x to the 7th, so the 7 is going to come out, then we're going to subtract 1 from 7. Yes? So 7, and that's multiplication here, because that's what it turns out, right? It's multiplication. 7x to the 6th power. And now you can just multiply 4 times 7, that's 28x to the 6th, and we're done. Okay? Now this is why students get a little confused. What was rule 1?
If it's a constant, it's equal to 0.
The derivative of a constant is 0, right? But we just had a constant, right?
But
And I told you to bring it along.
But it's also got a multiplication.
That's the key. That's the key. If the constant's by itself, the derivative is 0. But if the constant is attached to any function of x, like it is here, then it's just going to come for the ride. Understand? You just got to make sure that you don't accidentally say, oh, derivative of 4 is 0, and then you just kill everything off. That doesn't happen. All right, we good? Okay, let's look at the fifth rule. There are 28 rules. No, I'm kidding. Let's look at the fifth one. If you have, I'm kidding. Let's say you have some function of x, right? And you add to it some other function of x. All right, so you have two, let's say you had like 4x to the 7th plus 3x squared. So you had two separate things, right? So if you have a sum of two functions, then the derivative of the sum of these two functions is equal to this. So what is this rule saying? This rule is giving you permission to do what? If you have two separate functions separated with a plus sign, this is telling you that you can do what? Just take the derivatives individually. Just look at them separately, take the derivative of one of them, take the derivative of the other, and then add the two answers together. All right? That's what this rule is saying. Now, I'm going to add one more thing to this rule. If you replace this plus with a minus, so let's say they're subtracted, then the rule just, everything becomes minus. So you can subtract. This is a very nice rule, okay, because what it allows us to do is look at a function and then just kind of attack it piece by piece. Take the derivative of each piece one at a time. Make sense? All right.
Can I do an example for that one?
Yes, I'll do one. Yep. Is that clear though? All right, so here's an example for this one. How about we take one of the homework problems from last time? How about this one? It was number 27. Now you were supposed to do the limit on this, and it was probably pretty nasty, but we had a function f of x was 2x squared minus 7x plus 3. Right? That was a homework problem. And so you did the limit and all that stuff, and at the end you should have got 4x minus 7. Okay, so let's see how fast we can do this with the shortcuts, with these rules. First of all, our function has subtractions and additions in it, right? So that means I can do each of these individually. Okay, I can work on each one, just totally ignore that, and take the derivative. So on this one, 2x squared, that is a constant times a function of x, right? So what's going to happen with that 2 out front? It's going to stay there, right? It's going to come along for the ride, so the 2 stays. But then I have to multiply that times the derivative of x squared. And so I'll use the power rule.
Times 2.
So 2 comes out,
And then just x.
and then just x to the first power.
Yes.
So you subtract 1, you get that. Is that okay with everyone? Okay, so we're done with this, right? We're done? Then I'm going to put minus. Now I have 7 times a function of x. So the 7 is going to do what? It's just going to stay, right? It's going to come along. There it is. Now, what about the x? What's the derivative of x? 1. Right? That was your second formula. The derivative of x is 1. So I put times and then 1. You don't have to put the 1, but just to be clear on what happened to it, I'm going to put the 1 there. Is that okay? So this right here became those two. This x became that 1 right there, right? And that is it, but let's at least think through it. We have plus now, right? And now the derivative of 3. 0. So that time the derivative of 3 was 0 because the constant was by itself. There was no function of x there. Make sense? So our final answer, we just have to multiply 2 times 2 is 4. So we get 4x minus 7. And I think that you would agree with me when I say that's much easier than doing the limit, right? All right, is that a good example for you? So this formula said if you had this sum of like 2 functions, right? But we did it for 3 of them, didn't we? It works. This rule can be extended out. It doesn't matter how many pieces you have. As long as they're plus and minus, you're good. All right. I think we need to do a few more examples.
Page number 37. It wasn't one of the homework problems, but I tried it. And
You tried 37?
Oh, but that's square.
Yeah, but see, that's the problem. We don't have the chain rule.
So you would turn it into x plus 5 to 1/2?
Yes.
Okay, that's it.
Yeah, but with the rules we have so far, I haven't talked chain rule. When we do chain rule, then we can address that problem.
I was wondering, because that's
Yeah,
later.
that's why I didn't assign it. Well, you can do that one with the limit, though.
Yeah, no.
That's the thing.
This is a
You can actually do it with the limit. It's kind of messy, though.
long process. No, not quite.
Yeah, there's nothing. Yeah, it's not worth us looking at right now.
Okay, so I'm just like saying, I'm not trying to plan. I'm trying to
Okay, so here, let's see if you're getting this. Here's a function.
Sorry.
Why are you apologizing?
I was trying to sound like a complaint.
It didn't sound like a complaint.
Thank you.
Be quiet over there. All right. Okay, all of a sudden I've thrown this at you. Find f prime of x. All right, so let's just think about what we know how to do at this point. By the way, there are more rules coming. There are more formulas, all right? There are some that we will see. We're going to wait. Those are going to come after the test. We'll talk about those, all right? All right. First of all, I have subtraction and addition between these things, right? So I can do them one at a time. So that part I know. This first one, 3 times the square root of x. Now, how in the world am I going to deal with trying to take the derivative of the square root of x? Like, I haven't shown you a rule for that, have I? The only thing I've shown you is the power rule, right? So if you could somehow have x to a power, you can do it. Well, this is where, if you remember, day 1, I handed you a review sheet. And the first thing on that review sheet said, convert these radical expressions over to fractional powers. That's exactly why we wanted to make sure you were comfortable with that, because I'm going to convert that to a fractional power. I'm going to convert this to a power of x, but I'm going to move the x up to the numerator. So before I even begin taking a derivative, please understand I'm not doing a derivative right now. I'm just going to rewrite the function. I'm going to put 3 here, and then root x is the same as x to what power? 1 over 2. Now, I wrote this on the board at the very beginning of the semester. I'm pretty sure I reminded you that this is the formula we use to convert from radicals over to, these are called rational exponents. This book doesn't call them rational exponents. They call it fractional exponents. So, but that's the formula I'm using. So for this root, it's understood that there's a 2 out here. That's understood. And then x is to the first power. So that's why it becomes a 1/2. All right? Okay, any questions there? Minus 4x. I'm not going to touch x because I know the derivative of x, don't I? Yeah. Okay. And then this one, you must rewrite this as 5x to the negative 2. You must bring that exponent up. So again, that goes back to this property from 1324 or class before that. If you have x to the negative n, it's the same as 1 over x to the positive n. That's a property of exponents. All it says is that you can move things up and down. Just have to change the power to positive or negative. Okay, any questions? So do you all agree now that I have 3 different terms, 1, 2, 3, and all of these are things I can take derivatives of? Using the power rule here, right? I know the derivative of x is 1, and I can use the power rule here. What about these constants in the front, 3, negative 4, and 5? They're just going to come with us, right? Okay, so it's derivative time. Here we go. Derivative is, now I carry the 3 down, times, now let's take our time on this. This is going to be 1/2 comes out. X to the, I'm supposed to do what to that power?
Take 1 away.
Take 1 away. I'm going to write that down. 1/2 minus 1. And also on your review sheet, day 1, you might notice that if you go back and look at this, numbers 9 through 14 had you doing a bunch of computations where you had a fraction and you were either subtracting 1 or adding 1 to it. And the reason why is because we knew this was going to come up again. So you got to be comfortable with taking a fraction and subtracting 1 from it. We'll do that in a second. Let's keep going. Minus 4, that comes for the ride. Derivative of x was 1. I don't need to write it, but I'm going to. Plus 5 comes along, and now times, be careful here. What comes out front? Negative 2. All right, so you either need to have a dot with negative 2, or if you want to be real safe, just put this in parentheses. That way you know these are multiplied. This is not 5 minus 2. This is 5 times negative 2. And then you have x to the negative 2, and we're going to take away 1, right? Okay. So let's go and do these little side problems over here. I will not show all this work every time from here on out. I will just tell you, hey, yes, you've got to go to the side and do some work here. But just so you know what I'm doing, I'm taking this, right? And I'm going to do 1/2 minus 1, which is the same as I need a common denominator. So I rewrite 1 as 2 over 2, and that becomes negative 1 over 2. So 1/2 minus 1 is negative 1/2. I also need to do this one, right? So that's negative 2 minus 1, and that's negative 3. So that's what those two powers are going to become. So here we go. F prime of x equals, let's see if we can't put these numbers together. 3 times 1/2. Don't say 1.5. No calculators here. 3 times 1/2 is just 3 halves. You're just multiplying. 3 over 1 times 1 over 2. Multiply straight across. 3 over 2. Okay, so that's 3 halves. X to what power? Negative 1/2, right? We already found that over there. Then we have minus 4 times 1, which is just minus 4. And then over here, what do we get? Negative 10 or minus 10. X to the negative 3. Box it up. That's good. It is okay if you leave your answer with negative exponents. That is okay. You don't need to do anything. I know people are taught, don't ever leave negative exponents, but
We're not going to do anything with that like I symbol that we did here? The I?
like imaginary numbers?
Yeah.
No.
Okay.
No. Yeah. It's weird, but you know, you may have seen the imaginary numbers somewhere in the past. If you were to continue to study math, like math, if that was your major, you would go through pre-calculus, calculus 1, calculus 2, calculus 3, differential equations, linear algebra. You do all these courses, and then maybe after that, you take an elective where you'd go talk about I. Like you can go, we don't deal with I for a long time down the road.
We used to use I in air control. When I was controlling aircraft, we had to use imaginary numbers. It's the only way we could actually figure out bearing ratio and height changes.
Really?
Yeah.
So yeah, so that's one of those things where it gets a bad name, like, you know, it has a bad name like imaginary numbers.
If anybody's ever flown in a plane, they use imaginary numbers.
Yeah, so it's because at the beginning when it was first invented, people thought the person who was coming up with it was like kind of crazy. It was kind of like a crazy idea, and it just stuck. Yeah, so, but it's used in the real world all over the place, and yeah, okay. It needs a better name. Okay, how was that? That's okay? All right, let's, what, huh?
You got the negative 4 by
Multiplying 4 times negative 1.
5 times negative 2. But,
Times negative 2, yes.
Okay, oh, okay. So then you subtract. Okay, never mind. I see everything now. I'm trying to figure like how we got the end result because I was kind of lost with it, but now I'm looking at it again. I see you just connected everything together with the negative. The 1/2 minus 1 with negative 1. The negative 3 minus 1.
Just doing the arithmetic. Just take your time with it. Okay, shall we do another? Yeah. So in 1324, you probably only dealt with graphs of lines, parabolas. You talk about exponential and log functions a little bit in 1324. But in the real world, we want to be able to open up the type of functions, like if you're in a business model, right? You don't want to just be able to use parabolas or just lines. You want something else. So this is a very complicated function. But we can still find the derivative of it. And remember, the derivative of it gave us that slope of that tangent line, right? That's becoming something important that we're going to use later as we actually apply it to something. So all we're doing right now is just kind of using our new tools to see just how complicated our functions can get and how we can still attack them with the derivative. All right, so what am I going to need to do first here? Rewrite it. Okay, so you've got to be able to rewrite this where you have just x's to powers, right? You've got to start with that. So how about we rewrite this? How can I rewrite 1 over the cube root of x squared? 1 over x to what power? 2/3. Good. Okay. I agree. Now, what about this 4 over x thing?
I can just become 4x.
4. You could do 4x to the -1 if you want to bring it up. You could do that. Now, do I have to bring it up? This is a very, very important question. Do I have to bring it up? Let's think about this on the side. Let's say I gave you the function 4 over x, right? So I'm stepping away from that for just a second. If I gave you just the function 4 over x, and I asked you for its derivative, I'm going to put a star next to this. I'm going to put 3 stars next to this, because somebody's going to do this on the test and it's going to be wrong. All right, so I'm just wondering who out there is going to do this wrong. Let's see. What do you think the most common thing I see with something like this is?
Put a 1 on top and drop a 4.
I see people try and take the derivative of the top and bottom separately. So they do like, what's the derivative of 4 by itself? 0, and then derivative of x is 1, and then they say the answer is 0, or something like that. There's a problem. You've done something that I've never told you how to do. I've told you that if you have x by itself to a power, you can take the derivative, right? I've said if you have things added together, subtracted, you can take the derivative separately, right? I have never told you that if you have division, that you can do them separately. Have I told you that yet? No, and I'm never going to tell you that. Because there's actually an entire new rule that we have for dealing with division, and we haven't done it yet, all right? So you cannot do these separately. Your only hope at this point is to somehow rewrite this as x to some power. So we have to rewrite it as 4x to the -1 and then use our power rule, okay? So that's why I'm going to rewrite this way. So does that mean I'm okay here, or am I going to need to do something with this? I'm going to have to bring that x to the 2/3 up, which makes it negative, right? But I'll do that on the next step. This one right here, I'm not going to move the x up yet. I'm going to leave it on the bottom. Root x can be rewritten x to what power? 1/2. Okay. Now let's move all those x powers up. Let's get them all up to the top. X to the what? -2/3, right? When it comes up, just becomes negative. This one was already good. And then minus, this one will be 10, stays there, and x to the -1/2. And now we're ready, okay? We have not taken a derivative yet. We're ready for that now. All right, so here comes our derivative. And again, let's just take our time. This right here is just x to a power, so the power is going to come out front, right? Negative 2/3. Then I'm going to do x raised to the negative 2/3, but I have to subtract 1 from that. And that might not be something obvious to you that you can do in your head, so we might have to do that on the side. And then we have, what's our next thing that we write here? 4. Plus 4, just bring it. All right, and then what's going to happen here when we take derivative of x to negative 1? Negative 1 is going to come out front. And then we're going to have x to the, well, we had negative 1 there already, right? But we're going to subtract another 1 from it. So it can turn out to be a negative 2, but I'll do that on the next line. And then I have minus 10. And then for this one, again, I have a negative 1/2 comes out, and it's multiplied. And then x to the, I'm definitely going to be off camera here. X to the what? Negative 1/2 minus 1. You want to make sure by Monday that you're very comfortable doing that arithmetic. Okay? It was on your review sheet. I expect that you can do that. Go back and review it if you need to. But like from here on out, I'm not going to show the steps. I'm just going to calculate it. So this is going to be negative 2/3. That's this. And then x to the, does anyone know what that is?
Negative 1 or negative 5/3.
Negative 5/3. You said something, negative 1 2/3.
Yeah.
This is actually correct, but this is what we call a mixed number.
Yeah, that's why I flipped it back.
Yeah, so from here on out, we will not use mixed numbers at all anymore. All right? From now on, we will use this, which is called an improper fraction. That doesn't make sense. The proper thing to use is the improper fraction. All right? All right, that's what we're going to use. All right, so here, what's that? These two? So just minus 4, right, or negative 4. Then x to the negative 2, and then, these two together. Yep, plus 5. And then x to the negative 3/2. There we go. That's it.
That's the answer.
That's it. It looks ugly, but that's the answer.
Are we later going to go farther on and solve for this, or is this just as far as we can get?
All this is right now is we are just practicing using the rules. That's it. Because this is a business calculus class, we are going to be limiting the types of functions we actually work with in more detail later.
Okay.
We're going to be really dealing with polynomials like quadratics and things like that. We are not going to ever really mess with functions that look like this and go any further with them. But a problem like that really forces you to demonstrate that you understand how these rules are working, right? All right, one more. So if that's all I put on the board, you'd be pretty happy about that?
Yeah.
Okay. So I'm going to do all of that over root x. Now, I'll say this again. I said it a second ago, but I'm going to say it again. I've given you a rule that allows you to take the derivative of x to any power. I've given you a rule that says if you have pluses and minuses between things, you can do them separately. I have not given you a rule for taking the derivative of anything with division, right? I have not. And you see division here? Okay. You are not allowed to take the derivative of the top, so like do that, and be all happy about it, and then just look at the bottom and say, oh, I'll take derivative of that now. That is not allowed. All right? But how do we do it then if the only thing we know how to do is things that are separated with just powers of x's and no division? How can I even go after this?
Plug it in calculator.
Yeah? No? So let me ask you something. This is kind of off topic but on topic. All right, let's say I have the fraction 3 halves plus 7 halves minus 4, let's make it 11 halves. Can you combine these fractions together? Why? Because I have the same denominator. So what I would do is I would do 3 plus 7 minus 11, wouldn't I? 3 plus 7 minus 11 all over what? The common denominator 2. Is everyone comfortable with going from here to here? Okay, if I asked you to go from here back to here, could you? How? How do you go from here back to here?
Multiply the top right here. Wait, never mind.
Wouldn't you just take that over this, plus that over this, minus that over this, right? So if we have a single term in the denominator and we have multiple terms on the top, we can go and split it back this way, can't we? And that's exactly what we need to do here. See how we have a single term on the denominator and we have multiple terms in the numerator? We are allowed to rewrite this as x squared over root x plus 3x over root x minus 4 over root x. Do you buy that? You believe that? That seem reasonable to you? That's just using the property of the way we add fractions together. Now, by doing it this way, I'm actually going to be able to attack these one at a time. But then you're going to sit there and say, hey, they still have division, right? Like these each still have division. But we can use some properties of exponents. This one right here, specifically, that says if we have something to a power over something to a different power, we just write that something and you subtract the powers. So that's what I'm going to do. I'm going to rewrite each of these as powers of x. Notice I'm not taking any derivatives yet, right? I haven't said I'm taking a derivative. All I'm doing is rewriting everything. I'm rewriting the square root on the bottom. Well, on this last one, can we just move that? Well, no, I'll write it. Okay. Is that fair? That make sense?
Yeah.
Okay. All I've done is rewritten my root x's as x's to the halves. And now, this right here, and this last one we don't need to do anything because we can just pop that up and make it negative. But those in red will follow this property right here. Have I taken the derivative yet? No. I've not taken the derivative yet. Okay. So this first term right here turns into x to the 2 minus a half. Plus this next one is 3 and then x to the 1 minus a half. And this last one, all we said was we were going to bring that x to the half up. So that's what it is right there. Now we need to do a little arithmetic. 2 minus a half, you have to get common denominator. So this is going to turn out to be 3 halves. And then plus 3, and then x to the what? 1 half. And then minus 4x to the negative 1 half. We have not done anything to that. All right. All of that work that I've done up to this point was just to prepare it for the derivative. Now we take the derivative. Understand? All right. Why don't you try it? Just on your own. See if you can't take the derivative of that. See what you come up with. And I'll give you about, I don't know, 15 seconds? No, I'll give you like 2 minutes. See? What's up?
Could you have taken, I know you could have, that x to the 1/2, the bottom negative, x to the negative 1/2 and multiply through?
Yes, you could. Yep.
Okay. Can I have a review? I've got to go.
Yep.
So I can give it to my friend.
Yep.
Thank you, sir.
1, 2, you want 2? 1 for you, 1 for her? Okay.
Next Monday, right? Is that all class is going to be just?
All the whole class, yep, is the test.
I got to go teach vectors.
Nice, fun. All right, I'm going to start putting the answer up here. See if you're getting the same thing or not. This part in red was the part where I did the derivative. Everything else was where I was trying to get the function f right here. This was the function I got to, and I took the derivative of that, and that's here. All right, what do you think? Yeah. Yeah, practice. All right, let's take a look at the review. I don't want to put anything else on the menu today. Yes. The test will include this.
Oh, yeah.
Here we go. I think there's enough there.
Are you picking up those homework things?
Nope. Nope.
That's because you were trained by your whole
Okay, here we go. All right, let's take a look. Everybody have a copy? All right, so I want to talk through this. You need one more? Okay. No problem. All right, so number one, part A and B are converting from radical to fractional exponents, which was on the review, but we've actually seen that here today also, right? Number two is just again, a review topic. You know, can you multiply that stuff out and simplify it and make sure you know how to distribute and be careful with your signs and all that? So, I mean, I look at numbers 1 and 2 as being kind of like gimme problems. Not gimme, but you know, I mean, it's we're going to do more complicated math than that throughout the test. So those should be nice parts of the test. All right, number 3, factor. You need to make sure that you know how to use some sort of AC method for factoring, all right? And I've told you all that since day one, that I'm willing to help you learn a method if you don't know one, but I'm not teaching a formal method in class because it's a prerequisite for the class. So make sure you can factor. And then number 4, I give you 3 functions and ask you to find the difference quotient. Just the difference quotient, not the derivative, just the difference quotient. So there was a take-home quiz that you did where I gave you 3 problems to do. This is very similar to that. So just more practice with that. And then number 5, I give you a graph, and on the side there I ask you for some limits. So look at part A. That's saying the limit as x approaches -3 from which side? The left. Part B is -3 from the right. Part C is just approaching -3, right? Which means what? If it doesn't have the plus or minus, then you got to look at both sides and make sure they turn out to be the same number. If they're not the same number, D and E, right, does not exist. Okay, and then I ask you to find the limit as x approaches 0, and then the limit as x approaches 2 from the left. All right? All right, number 6, use the graph from number 5 above to state the values of x where the function is not continuous. I think we can answer that right now without actually, if you'd like, we can answer it right now. Can you tell me where the graph is not continuous? At -3. See, it says state the x values. So you see at -3 we have a break in the graph, right? The graph, like, it goes up and then all of a sudden you have to pick up your pencil and move down and then continue drawing. Anywhere you have a break or a hole, it's not continuous. So x is -3. Where else? 0. Where else? 4. That's it. Those are the 3 places it's discontinuous or not continuous. All right, number 7. You have to do some limits. So this is the one where you have to decide which part of the function you're using. So on part A, it says approach 0 from the left, right? Correct? So are you going to use the top function or the bottom function? You're approaching 0 from the left. The bottom function, because the bottom function is x less than or equal to 0. For part B, we're approaching from the right, right? And that means you're going to use the top function because you use the top function when x is greater than 0. And then part C says, hey, approach both sides, and those better give you the same answer. If not, it does not exist, right? And what about part D? Just plug 0 in. So if you plug 0 in, are you on the top or the bottom? On the bottom. Why? It has that little bar underneath the less than sign. Okay, that's number 7. Number 8's exactly the same. Well, not exactly. It's a little different. But the same question is just a different piecewise function. Number 9. Take the limit as x approaches 6. I give you a function, right? And I say, all right, let x approach 6. You always want to just try and plug 6 in first and see what happens. What would be bad if you plug 6 in and you get what? 0 over 0. If you get anything else, it's okay, and that's your answer. So like, let's say you plug 6 in, and let's just say that you get 2. Then your answer is 2. But if you get 0 over 0, what are you going to have to do? Algebra, right? So on number 9 and number 10, one of those limits is going to be nice, and you're just going to have an answer, a number. The other limits are going to give you 0 over 0, and you're going to have to do some algebra. All right, number 11. Find f prime of x using the limit definition. So that's like your homework from last time. Then I say, part B, find f prime of 4. So what do you do to find f prime of 4? Plug that answer, plug 4 into that derivative answer for x. And then number 12 is exactly like number 11, just I give you a different function. And I give you, what's f prime of -2 instead. And then 13 is use the basic derivative shortcut formulas to find f prime of x for each of the following. And that's very similar to what we did just now. Now I did do a problem there, part B, where I did decimals. Do you see that? So I just want to see how you do with that, because a lot of the functions that we're going to deal with later are going to have decimals in them. So you just use your calculator, bring that 2 out front and just multiply the decimal times 2 on your calculator, see what you get. Any questions?
So we bring calculators with us?
You can use a calculator. Yep. Okay, so it's only 1:20, so we have a couple of options of what we can do now. I mean, if you feel like you want to just go and take this and go sit with it and work on it on your own, you're free to go. If you want to stay and ask questions or have me cover anything that you're unclear about, I can hang out. We'll just kind of leave this last, 25 minutes as stay if you want. You're good to go if you want to go. I will post the solutions later. I do need to take attendance, sorry. I will post the solutions in Canvas. Just look, I'll send it as an email attachment. That way you all get it. Yes, sir. What do you got?
Are we allowed to use notes?
You're not allowed to use notes. Yeah, so for this test, let's think about what you're going to need to know. Let's look at this rule. This is a really good question. If we start at the front, you need to know the difference quotient. F of x plus h minus f of x over h, right? You need to know that. And you also need to know the limit definition for the derivative, which is the same as the difference quotient, except you put limit h goes 0 in front of it, right? So that's one kind of 2 things you need to know. Otherwise, is there anything else you need to know? Formula-wise? I don't think there's anything else formula-wise. Now later on in this class, like on the next test, I may allow you to use some sort of note sheet that you come up with on your own, because we do have a lot of different formulas and techniques and things. So, but on this test, I don't think it's necessary. Good question. Anything else? Any other questions? I'm going to pass this around. Go ahead and start it out. I'm going to stop recording, but anyone wants to ask questions or stay and